Welcome back, ladies and gentlemen, to the All in Crypto podcast. I am your host, All in Crypto, and today I am unbelievably delighted to be joined by Lude, the business development lead over at Crust Network. Now, Crust Network is a data storage provider that deals with decentralized data storage that are not only transforming the current world that we live in the Web 2 world, but also doing the same thing for Web 3. The first thing for me to ask is, Lude, how are you?
Hey, how are you? I'm doing great. First of all, thanks for having us on here. It's a delight to be able to talk to your community, to educate about decentralized storage, and yeah, to talk about this great DePIN narrative.
Yep, I am unbelievably excited. You know, this is a sector in the cryptocurrency space that is yet to really take off. And I think Crust Network are unbelievably well positioned to benefit from all of that. Really looking forward to diving into the more broad narrative of decentralized storage and also Crust Network and how you guys are really bringing it to not just the Web 2 world, but also the Web 3 world. I always really like to start with my guests with a little bit about themselves. Some people may be unfamiliar with who you are and sort of how you ended up in this space. So if you could maybe give us a brief introduction into yourself and how you ended up at Crust Network, that would be amazing.
Yeah, I would love to. So, as already said, I'm Lude. I'm the head of BD at Crust Network. Currently, I'm based in Germany, Central Europe. I'm with Crust now for the last 3 years now. It's already quite a long time in crypto terms. And before joining Crust 2021, I actually was involved with a startup in the software as a service industry. We built like a born in the cloud solution for business applications, which I successfully exited. And yeah, since then, basically, I always loved doing pioneering work, working on the forefront of like new innovations and technologies. And yeah, that's why I moved from software as a service in Web 2 to decentralized storage in Web 3, which is still quite close to each other, both related to cloud computing in one way or the other. And the switching it was not too hard for me. And yeah, I love the feel of Web3. I love the things we're working on to drive the world to like a better environment where we can put the ownership back to the users.
Yeah, fascinating. I find there's such an eclectic group of people in the crypto space. You know, like my background's in dentistry. It seems like a real good fit for you to kind of transition from the Web 2 kind of data storage world into Web 3, which makes you perfect, I guess, for pioneering Crust Network. Let's dive into Crust Network. You know, let's maybe start with a bit of an overview in regards to Crust Network, what it is in kind of as layman terms as possible, because I think there's a lot of people in the crypto space who aren't perhaps tech savvy. And to just give a rather simplistic overview of Crust Network before we really start to dive into the multiple layers, benefits, and offerings that Crust Networks brings with it.
I would say, to put it in the most simple term, Crust Network is a purpose-built layer 1 blockchain for decentralized storage and hosting scenarios. So everything you could use an AWS S3 server, where you store your data, where you retrieve your data from, this could be theoretically replaced with Crust Network. Just that, like, you don't have one centralized operator and service provider who's managing the infrastructure, who's doing the cache to order processes, and so on, but that you rather have like a permissionless, open, and fully decentralized network that's operated by multiple individuals over the entire globe. Where not one single person or entity has control over your data or even control over the network. And everything works on a consensus. And that's the beauty of the decentralized version of storage systems. Yeah, that's basically, to put it in the simple words. To go a little bit deeper, we are a substrate-based chain, which is usually associated with the Polkadot ecosystem. We also have 2 parachains, one for the Polkadot relay chain, but also for the Kusama network, which are connected right now. But we are not just limited to the Polkadot ecosystem. We also provide our services beyond, which means to the EVM ecosystem. So we have like a designated EVM storage protocol for Ethereum, for different layer 2s, but also for other independent layer 1 networks like Aptos, etc. We provide storage services for in like an omni-chain way. So we see ourselves as an omni-chain service for decentralized storage in Web3, but also Web2 developers obviously can leverage this beautiful technology for different kind of use cases where it makes sense for them.
Yeah.
Going back to the network, to the actual infrastructure, because we're talking about DePIN, which is nothing else but decentralized physical infrastructure networks. So obviously we provide this physical infrastructure. This is provided by our community. Currently, there are over 1,420 individual node operators that run nodes all over the world and provide their storage resources to this shared network. And currently, this makes up to an overall storage capacity of, I think, just above 640,000 terabytes, yes, or 640 petabytes, if you use like another. And since our launch of our mainnet, which was back in September 2021, we already processed more than 2.2 million storage orders via our network and via our decentralized storage market. So this as like a quick, brief introduction about the cosmos of Crust Network. But yeah, when we go into the details, you will see there's way more to it.
Yeah. Just as a kind of, I thought that was a brilliant overview. Because people often, Crust is dabbling in this area that we've kind of categorized as DePIN. Now, maybe before we jump into the difference before a decentralized data storage system and a centralized one, we could maybe just explain this concept of DePIN in a little bit more detail. So to kind of give you something to lead off on, if you look at how the internet is currently put together, the internet is kind of a coalition of protocols, hardware, and software. And the hardware enables the software and the kind of internet to work. So things like data storage, things like computing, things like the infrastructure that allows network. And the ownership of those physical, in the real world, they're actually computers or forms of servers. In the kind of current situation that we're in, pretty much the majority of that hardware is essentially owned by Amazon, Microsoft, and Google. And this kind of creates an interesting world. It's no coincidence that also these companies are the largest companies in the world. And actually what through cryptography and a distributed ledger is being solved here is how do we take the power back from these, call them cloud lords, call them whatever you want, and actually put that back in the hands of the people in the exact same way that Bitcoin is trying to do that with money or a store of value. So could you maybe extend a little bit on that and actually talk about this idea of DePIN and how Crust kind of enables a decentralized physical infrastructure that allows for people to use data storage?
Sure. Before I answer that, I would like to take a bow and generalize this topic maybe a little bit more to make it relatable. So when we talk about Web 2 versus Web 3, then the biggest differentiator is actually the part of ownership. And when we talk about ownership in Web 3, we usually think about ownership as part of a protocol, via DAO tokens, whatever. All those things represent ownership. You can own it in a non-custodial wallet. Nobody can take it away from you or enforce it or whatnot. When we're talking about DePIN and decentralized physical infrastructure networks, then we basically can translate or take this principle of ownership and basically transfer it to actual physical infrastructure. Like you said, those devices, those nodes, servers that actually are processing the software that's running on it, the most fundamental layer, if you want so. And DePIN basically brings this concept of ownership from like being able to own a part of a protocol, a part of a piece of software, to actually being able to own a part of physical infrastructure. And this contributing your ownership to like a common shared network, which overall can create revenue, and you as part of this obviously will receive incentives back from this. And this is basically the idea, looking at a big picture and trying to translate it from like the pure protocol part into the physical part. That's how I would see it.
Yeah, yeah. And let's maybe lead on now into some of the differences between a centralized system like Amazon Web Services and what Crust is doing, a decentralized. Let's just keep it more broadly and talk more about centralized versus decentralized systems, some of the dangers that we see with centralized systems that decentralized systems are kind of alleviating.
Yeah, I would happy to go down that road. Actually, I would love to share a few slides regarding this if you want so.
Yep, yep, for sure.
Because that visualize the entire issue a little bit better. Let me pull it up. Actually, was a presentation I also taught during Polkadot Decoded in Copenhagen last year. And yeah, before we talk about decentralized versus centralized, I really want to pick up on what you said earlier. This monopoly of those very few established cloud providers. And here, this actually is like a really cool graph that shows the amount of data created, consumed, and stored globally.
Wow.
And we see that like over the last decade, we had like an exponential growth, and just over the last 2-3 years, we created more data than we ever did before in the entire history. And this makes up to like 330 million terabytes of data daily in like 2023. Wow. And considering that like 65% of this data is in the ownership of like only 3 big players, which like, yeah, you name them, Amazon, Google, Oracle, I think, those guys basically own the biggest share of the data. And when we're talking about so much data and so little or so few players that actually handle those data, then this raises a lot of alarms in terms of centralization, centralization of power, centralization of ownership. And this is something we want to try to avoid so hard in Web3. So how do we get there? And how do we maybe move away from that?
Just to add there, Lude, very quickly, I absolutely love this graph, by the way, because this kind of puts into perspective just how important data storage actually is. And if you look at the world that we're moving towards, and I think we're both in agreement on this, it's going to become significantly more data storage dependent and more digital generally. You know, if you look at this world with things like AI, with things like the Internet of Things, with things like just the entire way the world is moving towards, this is an industry and the need for data is going to reach, these numbers will be a thing of the past, you know, when you look at the world we're moving towards. And in that world, if that world is controlled by 3 entities that have your data, basically own your data, that potentially is as dangerous in this new kind of world that we're moving towards. You know, economics and an economy of that world is going to be, I think, derived from things like data, things like compute, things like all of this stuff. You can't have 3 entities that basically have a monopoly on that. That almost becomes as dangerous as a central bank having a monopoly over money.
Yeah, it's messed up if you think about it. And what you also mentioned there indirectly is also very true. We don't just collect more and more data every year, but another very important trend is also that we become more reliant upon this data.
Yep.
And it's like we are reliant upon this data, then this also means we have to trust those very few players to actually handle those data according to the code of conduct, to not like mess around with it, to not censor it, and whatnot. So this dependency on this data becomes stronger and stronger as well. And we couldn't forget that. It's not just the amount, it's also the importance. Yeah.
Yep, absolutely.
If we're done here, I would move on to the next slide, maybe, because that's a beautiful slide as well. Should like maybe raise some eyebrows. Yeah, and I want to talk about the evolution of data storage. So how did we get to where we are right now with like all those centralized cloud providers, and how do we maybe move away from it? What's the solution for it? And I like to see this entire thing as an evolutionary process and not as like an revolution we suddenly have with all those possibilities blockchain offer. When we're looking back at Web 1, And like data storage systems in Web 1 were usually local storage systems. So big institutions run their own server infrastructure in their basement. They had their own hardware. You as end user, you had your HDD drives, your USB sticks, whatever. And the good thing about this was that you maintained full ownership over the hardware, and there was also the data in it. The issue was that like you had like a very limited accessibility. So it was hard, it was very, not very convenient to maybe access this data, especially when you want to access it from another device, from another location, when you travel. So this made it a little bit isolated. And the success of Web 2 movement basically is based on the convenience we gained. We have now the highest accessibility possible. We can adapt our resources with like just a few clicks on a slider, scale our capacities, are fully dynamic and flexible. We follow the anywhere, anytime principle, can share data easily. So we gained a lot of convenience, super high accessibility, but the issue is we lost the ownership. Because the ownership now is part of those few players that actually run those large infrastructure centers and softwares. And the issue with this is we always have to put our trust in this third party to handle our data correctly and so on. And now we are looking at Web 3. And I think that like decentralized storage systems is just like the next evolutionary step of centralized storage systems, which allows maybe to combine the beauty out of both worlds, which is the accessibility from Web 2, but also the ownership part like we are used to from Web 1. And the best part about this is we don't have to trust anyone because everything is like operated and backed by a trustless blockchain code. And that's the entire idea behind it. And yeah.
Mind-blowing, absolutely mind-blowing. I think that really shows it's a common theme that I consistently come up against or run into when I look at multiple different forms of a use of a distributed ledger to decentralize, whatever it may be. It could be identity, it could be file, it could be whatever. Data storage is a perfect example. I think that the slides you put up there really explain that beautifully. The theme that I constantly see is we started off with ownership, then with the rise of the internet, we gave a lot of that up. And now we're kind of moving back to having the best of both worlds, where it's not only convenient, but we have the ownership of it. And again, in a more and more and ever more digital world, we are going to need, it's going to be of the utmost importance to have control over our own data and to be able to move away from three companies that essentially could end up controlling the entire world through the manipulation of data and the infrastructure of the internet, because it's an integral part to all of our lives. Let's talk about some of the actual benefits, though. So, of course, really what we've spoken about is your sovereignty over your own data, so the fact that you own your own data. But that's not the only benefit when it comes to a decentralized storage over a centralized one. Could we break down some of those differences and benefits?
Sure. One important thing definitely would be censorship and immutability. I want to bring up maybe one example.
Yep.
I don't know how long it's back now, 1.5, almost 2 years, when the FTX disaster basically happened. Users who formerly minted their NFTs via the FTX interface basically lost all their metadata after FTX went down. And this is because FTX basically used a centralized service provider to store all metadata. Maybe I want to explain 1 or 2 sentences regarding this NFT, because an NFT basically consists out of 2 things. On the one hand, you have the contract and the token that runs on chain. And on the other hand, you have the actual media file, the PNG, the MP3, the JSON file that defines all the characteristics of this NFT and whatnot. And this basically is stored in not directly on chain, but on another place. And the contract just points to this location where all this stuff is saved. So FTX used a centralized provider to store all this data, but obviously when FTX went bankrupt, they stopped paying for the centralized service provider, and the service provider obviously has no reason to maintain this data, and the data was all gone. So when actual NFT owners wanted to look up the NFT, all they saw was the hopefully not too expensive for error page, and the data is vanished. This couldn't happen to you, for example, on decentralized systems that are designed to be immutable, designed to be censorship resistant. This is one big argument for decentralized storage systems. Other arguments, probably looking at the just physical hardware side of things, would be single point of failure events that can happen to centralized infrastructure. So if there are any outages, if there are natural disasters, we have seen it multiple times, floodings or like data center burns down, anything can happen. In best case, you have one redundancy somewhere at centralized services, but then you mostly already have to pay for it. This comes all built in with decentralized storage systems, because at least at Crust network, we have like a built-in redundancy. Currently 33 replicas per every file you upload,
Wow.
which is quite a lot. And this file is distributed all over the entire globe. So a node in a node in San Francisco, but also a node in Shanghai. And also this also helps to like maybe go also into the direction of like kind of edge network, because the more nodes hold the file, the higher is the probability that you're close to a node for like a low latency and so on. But there are also other advantages. For example, when we're looking at costs, cost is super important factor, especially for large data consumers. And currently, we are more than 90% cheaper than traditional services like AWS, Google Cloud, and so on. And I think overall, this makes a great package for users to actually experiment with this technology. I have to admit that maybe it might not be there yet for all possible use cases, but for many of those, especially looking in Web3, decentralized storage is like the perfect solution and a better alternative compared to centralized services.
Yeah, there's a whole host of benefits actually that decentralized systems offer over centralized one. Of course, that censorship resistance, the price point of view is actually a big one. You know, why would people, I always get this question, okay, well, why would you use a decentralized data storage provider? Well, let's just say you don't care about owning your own data, because I do think there are, unfortunately, a group of people out there that aren't really that fussed. You know, it doesn't seem to be in their face when it comes to the likes of like Facebook and the power that they have over them. You know, I don't think for some people that's going to become a big enough problem until it really is a big enough problem. But let's say you don't care about that. Look at it from a price point of view. 90 near enough % cheaper or thereabouts. That will fluctuate, I assume, than decentralized systems. No one single point of failure. So your data is actually more secure. And of course, you should definitely care about the fact that you actually own your data as a result of this. And you don't have any kind of an issue arise that you'd have with a centralized system. So for me, decentralized systems are better. I really do think that across most things. Maybe at the moment we're kind of
you on board.
Yeah, I'm totally on board actually. And I was really excited about this because it just makes sense. I love to see a broader application of a distributed ledger than just Bitcoin. I'm so against the Bitcoin maxis that call everything else, you know what, we know what they call us. You know, it's just simply not true. And actually, it was Hal Finney himself who said, Bitcoin is a global sort of ledger. There are so many applications for a global ledger. It's unreal. And Trust Network is a perfect example of this and actually revolutionizing an industry that needs to be revolutionized. Let's talk actually about so we've kind of crossed over into Web3 a little bit, but I want to talk about the irony right now in regards to Web3, because it seems ironic to me that we've kind of tried to create new systems and move away from the powers that be and the centralized systems. But in doing that, we've actually totally reintroduced the centralized systems. You know, you spoke about NFTs. The vast majority of NFTs across the board are stored on Amazon Web Services. If you look at nodes that run on Ethereum, 30% of nodes on Ethereum run on Amazon. Cardano, it's about the same. So actually, not only are we revolutionizing the world that we currently live in, we're also revolutionizing the Web3 world, which has kind of introduced a problem that you guys are solving with these decentralized systems. Could we maybe talk about that?
Sure. Yeah, like I already said, I feel the ownership part is the biggest differentiator, but suddenly we say like, okay, that's where we draw the line. Here we don't need all those principles we're fighting for anymore. But on the protocol side, we still want to have everything as decentralized as possible. And yeah, that's why I think it's a little bit ironic to say we are building a decentralized vision for our users and so on. But then when you look a little bit deeper and look at the actual most fundamental physical layer, then you often discover that, yeah, in the end, the code is still run on centralized infrastructure. And obviously, this brings all those issues with it, like we talked about before. The issue to be censored, the issue that like this provider suddenly can decide, no, we don't let you host this service now anymore via our solution. What would happen if AWS and Hetzner, with like another huge provider for Ethereum nodes, say, okay, we're not allowing Ethereum nodes anymore, and suddenly 60% of the network breaks away. This is something like obviously we can avoid with decentralized infrastructure. It's a little bit harder to combine computing and storage right now for decentralized storage systems, but there are projects working on that. Solutions that take like storage providers, computing provider, and build like cloud services out of it. We also work with a few partners in this field. The Epsilon, I don't know if you're aware of them, but they build like
a
software as a service platform for Web3 services. And yeah, I think that's the way to go. And I hope finally every builder eventually will wake up to it. I think I mentioned it in our small talk before we actually started recording. A lot of effort we do at Crust Network, or yeah, we spend at Crust Network is actually educating builders, developers, users. Although they're super familiar with blockchain, with Web3, with coding, and so on, we feel there's still like this missing piece of the concept of decentralized storage. So education is very important. But I feel that the community or the overall market is slowly waking up to the issue, and there are enough successful projects forming around this narrative. And I think this would create just additional awareness. So every additional project in this field is good for the topic overall.
Yep, I absolutely agree. And I kind of want to move on in just a second to the difference between decentralized storage solutions. You know, Crust Network isn't the only one out there, but I think you guys have taken a different approach to many of the others. Before I do that, though, however, I want to talk about entirely new markets that could open up on the back end of data. So I believe there's a concept in regards to actually turning your data into an NFT, you know, and there's a kind of interaction with social media and kind of Web3 more broadly that you can then have with these NFTs. So how decentralized data storage will really empower people and kind of enable data markets. Could we maybe talk about that? You know, this kind of new thing that's arising from what you guys are facilitating.
I like to call it DataFi, maybe if you want so. But this is something obviously where we need decentralized storage systems in place first before we actually talk about DataFi, because to have like a DataFi economy, you need to have the principle of ownership and being able to transfer this ownership, including all rights and benefits, and this in this case is provable on chain on a public ledger. So you need to have some things in place before we actually can realize this DataFi economy in like a totally Web3 native way. And that's what we're trying to realize at Crust Network as well. And I think you mentioned it with NFT storage capacities, which is one of our products we released last year. It's called Crust Cloud, and Crust Cloud is introducing, we call it Web3 storage buckets. But basically, is an NFT that represents a storage capacity on our network. So basically, it's like any other NFT contract. You can mint your NFT from. We have like a nice user interface, and you can mint a 10 gigabyte bucket, 100 gigabyte bucket, or maybe a 1 terabyte bucket.
Wow.
And after you mint this, you own this bucket like you own any other on-chain asset or any other NFT via your MetaMask, via your Coinbase wallet, whatever non-custodial wallet you're using, and can access this bucket all the time with the authentication of your wallet. So you can upload data to it, you can retrieve data to it, you can share data from it right away. And the cool thing is that, like, for the very first time, we actually will be able to treat our data and our data capacities in the same way we treat our other on-chain assets. When you think about our normal tokens, our NFT PNGs we hold, with staking positions, or not usually, but like always, we have like a proof of ownership on chain where you can see that, like, I hold this position, I'm owner, my wallet is the owner of this. I can transfer those assets between my accounts freely. So I can transfer it from like account A to account B. And I can usually trade those assets on different marketplaces, but we can't do it for our data yet. And by basically using the vehicle of an NFT and being able to store data in this container, which runs as NFT, is a new concept which really allows the users to maintain ownership over his own data. A very good example to show the benefits of this is decentralized social, also
Yep.
a trend or narrative that's building up slowly. When we're looking about current Web2 social platforms, YouTube, Facebook, Instagram, then those platforms create huge amounts of data, user data, which should be considered maybe a little bit private, a little bit sensitive, depending on what you care there. But right now, when we think about the data flow, what happens? Like, you upload your selfie from your phone camera to Instagram. What happens? You actually upload it to like the Instagram infrastructure, to the servers. They maybe use AWS in the background, maybe they run their own infrastructure, who knows? But in the end, it's like one centralized entity again, who holds this photo, who physically owns this photo, and which you have to trust again to not like mess around with it. And when we're looking at Web3 decentralized social platforms, then we might have like a decentralized way of logging in, of creating an account. But in the end, when we upload our data, we still upload our data to the platform operator. And we don't know if this decentralized platform operator uses AWS, Google Cloud in the backend to actually store the user data, or in best case, he actually might use someone like Arweave, like Filecoin, or like Crust. But even if he uses Arweave, Filecoin, and Crust, then he is still the one who's guaranteeing the data, because he's the one paying for it eventually to be stored. So what we can do now with those Web3 buckets is, which you can own in your MetaMask, that like every EVM account, for example, crypto account, which you log in with on your decentralized social platform, already owns one of those buckets. And every user content, every selfie you upload, you don't upload to the operator, but you upload it to your own bucket. And from your own bucket, basically can just be displayed on the platform via a normal link where it can be retrieved from, crawled from, and via this, you always maintain the ownership. The cool thing is you also can move this content from platform A to platform B if you would like to. And we can't do that with centralized service providers where we are locked in, where we have to trust in this provider. And where we always are dependent upon a third party kind of.
It's really interesting. An example that's rather a funny example is a good friend of mine who happens to be an amateur bodybuilder. He runs his business off of social media. You know, he's always, you know, if you've spent that long getting your body in that sort of a shape, you know, you know how the bodybuilding game goes. You know, they're constantly taking, yeah, absolutely. And I remember coming into the gym one day, and he was annoyed, to be quite frankly, because Facebook had decided that they wanted to take his entire page down. And all of the data, we're talking 15 years worth of pictures and data and business information gone. And that's just one rather funny. I mean, if you knew the guy, you'd be laughing with me because, but it's just one perfect example of actually what Crust's network is doing, actually solving this. You have an assurance that everything you're putting on these platforms, for most people that aren't doing things at the moment, okay, but I think we're moving to more and more of a world where they are looking to regulate the internet. I do believe they're doing that, and the social platforms that are big on there. I mean, it seems crazy to me that between Meta or Facebook, as previously known, WhatsApp and Instagram, reached over 4 billion people last year.
Yeah. Same
They
numbers.
do 4 billion people even use the dollar? I mean, you can see just how big of a PowerPoint these people have, and they control all your data. This is about I hate to say that, liberating people in some regards, giving them power back to their digital world, and it's becoming more and more of a digital world. I'm so on board with everything you guys are doing, and the whole NFT, and we always like to add "fi" to the end of everything, don't we? DeFi, real fi, ReduFi, DataFi is brilliant, and I'm really looking forward to what kind of derives from that. Let's talk a little bit about the difference in regards to decentralized data storage solutions. So you mentioned Arweave and Filecoin. Let's talk about how Crust differentiates. I don't know if you've got really anywhere you want to go in regards to that route, looking at how Crust's actually look to prevail against some of the other maybe data storage plays out there.
Sure. So on the most high level, I would like to separate two different directions. We have on-chain based storage, which would be represented by Arweave, and we have off-chain based storage, which would be represented by Crust, by Filecoin, Storj, and others. SIA would be one in this category as well. On-chain based storage is probably the most decentralized form of storage, looking at the technical parameters. Because like with any other on-chain based system, every node has to carry all the data, which is great for decentralization, but which obviously has other issues. For example, scalability.
Yep.
Due to the fact that like every node literally joining the network before it can host new data has to carry all the old data.
Insane.
You can think what that means for the future. I think they're working on some solutions that are supposed to help with this, but in the end, the big issue of scalability always will be the limit. And I think the entire Arweave network currently hosts 150 to 200 terabyte of unique data. And this is just like the normal user might have more,
Yeah, yeah.
And businesses, especially businesses, but like, yeah, it's really good for very high valuable data. Let's say if you want to put your NFT collection on it, and like, you can do that, but obviously it's super expensive. It's, I think, currently around $10 per gigabyte, but it's permanent. It's permanent storage. We have to say that it's permanent storage.
Yep.
Designed for 200 years, I think. But yeah, that's about Arweave. So it's high costs. It's not really scalable. Use case scenarios are very limited. Yeah, that's when looking at Arweave. And we have off-chain based systems like Filecoin and Crust.
Yep.
And SIA, Storj, etc. And there I would maybe open two more categories, which is IPFS based systems and how I want to call it, individual storage system. Like IPFS is like a current kind of system, which is already an existing thing. In itself, it has nothing to do with blockchain, but it's also an open distributed network of nodes that basically form one common network and which is open for the user to use. And this protocol is unique in a way that like it addresses data in a specific way. It addresses data by directly addressing the content and not the location of where the data it saves. It is saved. This makes it immutable by design, because not one file, or let's say the file behind the path can't change. You point to the file directly.
Yep.
In centralized services, a normal HTTPS-based system always points to the location of the file. But if you change the file in the actual location, then it wouldn't be immutable. So that's IPFS. IPFS is cool in this kind of sense, but it also has issues. For example, that it's not incentivized. This means node operators won't get any rewards for storing your data. And on the other hand, when you don't pay for something, then you obviously can expect any guarantees. And that's exactly where Filecoin and Crust Network steps in. Those projects basically provide this incentive and service layer on top of IPFS, which actually lets users receive guarantees for their data storage in exchange for like a small fee they pay to the network. And in this sense, Crust and Filecoin are pretty much comparable. And when we're looking at the differences between Crust and Filecoin, then one of the big differences is the efficiency of our protocol. So Crust, for example, doesn't need any energy extensive GPU power. Obviously leads to like lower investment on the node operator side, to lower energy costs, and which in the long run obviously will translate into lower storage prices for the end consumer. Then Crust has like way higher interoperability than Filecoin has, which means that Crust has their on-chain storage contracts deployed to multiple ecosystem. Like I said in the early, we follow this omni-chain vision. So users from Arbitrum, for example, can call the Crust storage contract on Arbitrum chain directly, pay with Ethereum to the contract to actually leverage our services. Users on Aptos can pay with Aptos in like a storage contract that's written in the Move language on the Aptos chain to interact with our storage services. So this native interoperability for builders of their own ecosystem is something that makes Crust unique, and something that like Filecoin or others don't offer. Another very important differentiator between Crust and Filecoin is how our order system works, our storage market. I like to call Filecoin pseudo-decentralized. And I do that. I like to call them pseudo-decentralized because in the end, you still have a one-to-one relationship with one specific storage provider. So you have this market, you create a deal, and then you create one deal with one specific storage provider. It's basically like a taxi system. When I compare the taxi system with an Uber-based system, Crust would be Uber, because with Crust, you don't have a relationship with like one specific storage provider. You have a relationship with the protocol. The protocol basically takes care of the rest. Make sure that like storage provider pick up the data, make sure that your data is replicated in like a sufficient way and in sufficient numbers. And so you interact with the protocol. And this is like this taxi versus Uber. Filecoin is the taxi. You like call the taxi driver, one-to-one relationship. The same taxi driver comes, picks you up, you pay with him and whatnot. With Uber, it's different. You don't interact with the cab driver itself. Same with Crust. You don't interact with our storage provider. You interact with Uber or with Crust, with our storage platform. So you say, I want to store a file. And then like at Uber, where Uber sends you the next driver, quotes you the price, and does the entire purchase to order process. This is all handled by our platform and not by like single provider. So yeah, you don't have this one-to-one relationship. You always have this one-to-protocol relationship. And that's very big differentiator in our order process. Yeah. And
yeah, absolutely.
There obviously are a few more differences, but I think that would go too much into detail here.
Yeah. No, I think that was comprehensive enough. I think people often look at data storage providers and they don't quite know the difference between them. They don't quite know the different kind of routes that they've gone down, but I think that was actually comprehensive enough to kind of give people a good understanding of how Crust kind of separates itself. I love that analogy of Uber versus a taxi driver that you just ring up and you have a relationship with. You're more interacting with a system that has multiple taxi drivers, and that's your interface. I think it just paints for this really exciting, project that you guys are working on and you're building and you've been building. How long has Crust been, when was the initial founding of Crust? Was it even called Crust Network at the start, or?
Yeah, it was called Crust Network at the start, but we're a real OG project.
Yep.
So I think we launched 2018, end of
Wow.
2018. And we have been one of the very first projects actually being connected to the corporate testnet back then, provided by Polkadot.
Yep.
And yeah, before we launched, there wasn't even the concept of parachains and crowd loans on Polkadot.
Yes.
So that's why it took us a little bit time actually to score our parachain slot, because all those new projects that like basically onboarded after the vision was clear, dedicated like a huge chunk of their token for like the specific crowd loan. So when we did the tokenomics back then, we obviously didn't like reserve a huge chunk for this kind of crowd loans, which wasn't foreseeable back then. But yeah, in 2021, we managed to like receive the, or no, 2021 or 2022, and we received the parachain slot for Polkadot. Yeah. But one of the very first projects onboarded to the corporate testnet back then, I think, third or fourth project actually, yeah.
Wow, absolutely fantastic. And sort of where would you say Crust is currently at? So we've spoken a little bit about the capacity that Crust has. Where would you say Crust is at, and where is it going moving forwards? Like, so what's the current status of Crust as we speak today? And then, once you've answered that, and I'll maybe ask you after you've answered that, what's the vision for the rest of this year kind of moving forwards?
Mm-hmm. Yeah, so one big thing is keep pushing for our omni-chain vision. So right now, for example, just last week we deployed our test nets, our smart contracts to the Blast testnet. So we want to make it as easy as possible for all developers of different ecosystems to actually leverage our services. Because we also feel that like this is very needed. Then we saw very recently a big partnership we actually announced with Algorand. I
Yes, I
don't know
saw
if you're
that.
aware of them.
Yep.
But Algorand pretty heavily, it's integrated with Crust Network. You will find us soon in the documentation. We will do some developer bootcamps around Crust and Algorand integrations. We also will see the very first projects onboarding to Crust Network. So this is very interesting for us. But we also still like try to improve our products all the way. For example, recently we did that with an on-chain based encryption services, because IPFS in itself is like a public file storage system. And if you want to have your privacy, then you need to encrypt it before you actually upload it. You can do that with local client-side based encryption. But again, then you have the issue that you have to have the key always with you. You need to export it, import it if you want to access your data from another device. And we work, for example, with Oasis together to realize on-chain based encryption. You can store your encryption key on-chain in a secure environment, which is only authenticated via your Web3 wallet, to encrypt and decrypt your files from anywhere in the world.
Wow.
So we obviously try to improve our products. We try to listen to our users, to our customers, to realize those features. But also on the infrastructure side, obviously we are trying to build out our node operator community. Recently, we launched a community gateway program where we basically incentivize users to run gateways for Crust Network. They get paid for this. And another thing we spend a lot of efforts on recently, maybe not, we shouldn't talk too much here about this, but
Okay, here we go. Get ready for the alpha, guys. There's going to be a leak of something coming up here.
but we're working on a data availability solution as well for
Wow.
the Ethereum community, but also for the Polkadot community. And we recently, for the Polkadot community, we applied via the Web3 Foundation's Futures program to actually realize a project that's called SubDA, or Substrate DA for data availability, which is basically supposed to become a data availability and inscription solution for the Polkadot ecosystem.
Wow.
I have to admit, data availability works quite different on Polkadot than it works on Ethereum. But this doesn't mean that we couldn't use and utilize this technology for many other beautiful use cases. For example, we want to introduce those block transactions to the Polkadot community. We use those block transactions to actually store data in like an on-chain environment via our data availability network. And we also see different movements of projects like Tansy, which are moving towards app chains on Polkadot, and they again would kind of need a data availability solution. So there's a lot of dynamic in this field as well, and data storage and data availability is quite related in the way that like both systems still need to store the data. They still need protocols and mechanisms to guarantee the availability of the data. They still need to have some kind of incentive and slashing mechanism to make sure that the data will be maintained, that you have honest players in the network. So in those kind of things, data availability and decentralized storage is not too far off from each other. And that's why it was for us a logical road to explore at least. And let's see what we get as feedback from the Web3 Foundation, from the Polkadot community overall. And we just recently actually went public with this by introducing this concept to Polkadot community at the Sub-Zero Developer Conference in Bangkok just a couple of days ago here.
Wow. Do you know, just talking to you, I mean, this has been so educational for me. I can't wait. You know, I'm somebody that's personally very interested in Crust Network, somebody that's really looking forward and kind of, I think, but maybe this is me being a bit too big-headed here, understands the concepts that you guys are trying to pioneer and the kind of solution that you're offering, not just to the Web 2 world, but also to the Web 3 world, which is in dire need of decentralized data storage. And it's not just that. What we've gone over in this interview is so many different, you know, people think about data storage, they perhaps equate it with one use case. No, the use cases for data storage are far and wide. We, at the start of the interview, looked at just the demand for data thus far and how it's going to grow. And actually, through facilitating decentralized data storage, you are likely going to be creating entirely new markets. Call it DataFi, call it whatever you want. This is nothing short of exciting. The whole thing from start to finish has been honestly an honor and an absolute pleasure to have you on the show, Lude. I don't know if there's anything else that you want to kind of finish on before we wrap things up. We will leave links to Crust Network, all of the socials, where you can find out more about Crust Network. And guys, I'm absolutely encouraging each and every one of you to go and check this project out. Also, Lude, I don't know if you've got a social account you want to link people to, you know?
Yeah, on Twitter, you can find me under the handle the Jesus Crust.
Oh, wow.
_ Jesus Crust. And maybe some last few words. I also want to encourage everybody listening to this to try out this awesome technology. And you can do that by visiting trustfiles.io, which is basically a Dropbox-like solution for personal cloud storage. You can just log in with your MetaMask account, with your Substrate account. We have multiple wallets that can connect to it. You can just upload your data to Crust Network with easy drag and drop, with just a click of a few buttons. And we also have a freemium version, so you can try it out totally for free, and you can see how easy it actually is, and that the feel can be the same as it is and you're used to from Web 2.
Yeah, we'll
link that as well, trustfiles.io.
Yeah, we'll leave links to everything in the description.
Perfect.
Honestly, it's been an absolute pleasure, Lude. you know, I can't wait to have you back. So I am hoping that you're going to agree to coming back on. Now that I've got you on camera, I don't think you could say no, really.
No, I'm happy to be back with new updates, maybe regarding our data availability network for Polkadot. But yeah, I had a great time as well. Thanks for having me on. Thanks for giving us the opportunity to represent Crust Network, what we have to offer. And yeah, we are also looking forward to like the future with way more decentralized storage applications than ever before.
Yep, it's been an absolute pleasure, honestly. And guys, you know what to do. Go and check the links out in the description. Go and head over, go and try their data storage solutions. Also, check them out. You know, this is a really interesting project. It's one that I'm personally interested in, and I encourage everyone to go and check it out. It's been an absolute pleasure. Thank you very much.
Thank you.